Hello everyone. Today we are going to learn an important topic in VLSI physical design called clock tree synthesizers. It is commonly known as CTS. I am Mr. A. Suresh Kumar, Department of Electronics Engineering, K.S.Rangasamy College of Technology, Tiruchengood. So in this lecture, we will cover three main points. The first one is what is clock tree synthesizers, and the clock tree algorithms, and the clock skew. The clock tree algorithm means the different ways to distribute the clock, and the clock skew in the sense the time difference between the clock signals. By the end of this lecture, you will clearly understand how clocks are distributed inside an IC. So this is a VLSI design flow. The clock tree synthesizers is a stage in a physical design flow. It comes after the placement and before the routing. The main goal of CTS is to deliver the clock signal to all the flip-flops in a balanced manner. This ensures all the sequential elements are receives clock at the same time. And the next one is what is CTS? The clock tree synthesizers is a process of distributing the clock signal from its source to all the clock sinks such as flip-flops and latches. During this process, we insert buffers and as well as inverters. The main objective of the clock tree synthesizers is minimize the clock skew as well as minimize the insertion delay. So the CTS, it is balance both delay as well as a skew. And the next one is a clock tree algorithms. There are several clock tree structures are used in the industry. The first one is a H tree. So it is a most commonly used algorithm. And the second one is a X tree. And third one is a binary tree. And the fourth one is a fishbone tree. So each structure, it has own advantages and also the drawbacks. So and the next one is a H tree. So it is a most famous tree methodology. So H tree is the most popular clock tree structure. Here the clock network is look like a letter H. The features of a H tree is the clock will be split symmetrically. So in all the portions the clock will be delivered to the symmetrically. So the path length is equal to all the sinks, and also it will be provide the low skew. This structure is suitable for the regular and symmetric layouts only. So and the next one is a X tree. So in the X tree structure, the clock branches spread in the diagonal directions. So here the advantages of this X tree methodology will cover the large chip area, and it is useful when the sinks are spread irregularly. But it is a more complex routing, and also it is a slightly higher skew compared to the H tree. So when we are using the H tree, we can obtain the minimum skew, but in the case of X tree, it will reach the high skew. So and the next one is a binary tree and fishbone tree. So in the binary tree, the clock is split into the two at each level, and also it is look like a normal tree. It is also simple to implement. Whereas in fishbone tree, it is a main trunk with side branches. So we have the trunk in here, main trunk in here, which will connect all the side branches. So it is used when the sinks are placed linearly. So and the next one is a clock skew. It is the most important one. The definition of the clock skew is difference in the clock arrival time at the 2 points in the circuit. So mathematically we can refer it as del of ij is equal to ti minus tj. So here where ti is a clock arrival time at the point j, and the tj is a clock arrival time at the point J. So and the next one is a positive skew. So here the positive skew occurs, so clock arrives later at the destination of the flip-flop, so compared to the source flip-flop. The effect of the positive skew is, so it will be set up the timing improves and also hold timings before the words. So the positive skew, it is a good for setup, but it is a bad for hold. So and the next one is a negative skew. The negative skew occurs, the clock arrives earlier at destination flip-flop compared to the source. Here the effect of negative skew is, it will be hold timing improves, the setup timing becomes a worse. So negative skew is a good for hold and it is a bad for the setup. So here, so in this picture, so we will see the positive and negative skew scenarios. So the first picture will show the positive skew and the second picture show the negative skew. So in the positive skew, in the sense the both the data and the clock will be travel in the same direction, but in the negative skew, in the second diagram, the data will be travel from right side to the left side, but the clock will be travel from the left side to the right side. So this type of scenarios, so which is called as a negative skew. So that brings end of this lecture. So today we learned, so what is a clock tree synthesizers and different clock tree structures and also clock skew and its types. So thank you for listening. Thank you so much.